We've learned that a method is a collection of code that's grouped together to perform a task or action. Often, a method will need some information to complete that task. For example, consider this method that prints the area of a circle using the formula pi r squared. We'll approximate pi as 3.14, and the radius is 14.5. To square that, I'll just multiply it times itself. This evaluates to 660.185. Actually, because we're dealing with floating point numbers, we get a slightly imprecise result with a bunch of decimal places, but at this stage in our learning, we won't bother with rounding that off. The problem here is, every time we run this, we're going to get that same output because my arithmetic operations are using literal constants that won't ever change. Let's look at how we might call this from our main method. This code uses a readline statement to get input from the user, and then calls convert.toDouble to store it in a variable called radius. So we just need to use that variable in our calculation, right? As the Beatles once said, "Because I told you before, oh, you can't do that." You can't do that. A variable only exists inside the code block in which it was declared. We call that the variable's scope. So the radius variable can only be accessed within the main method, and if we write code in the print area method that tries to access it, our program won't compile. It's out of scope. One solution students often try is to move the declaration statement outside of main, so that the variable scope is the whole program instead of just one method. The Beatles didn't have a song called "You Shouldn't Do That," but you shouldn't do that. Maybe Tom Petty can help. It will work, but that's what we call a global variable, and we avoid those whenever we can. For now, you should avoid it because you won't get any points on assignments if you use global variables, and I guess if you get a job coding, you'll just get yelled at by your boss. We want to get in the habit of keeping our data compartmentalized. If a different method needs that value, we can pass it, like a football. To do that, we define a special kind of variable in our method called a parameter. A parameter catches a value that's passed when the method is called, and we can use that parameter however we want. To create a parameter, you'll declare the variable right inside the parentheses in the method header. A few things about this identifier. First is that we can name it whatever we want as long as we follow C#'s rules for identifiers, like not starting with a number. And since our parameter has a different scope than main, we could even use the same name and call it radius. What was that Tom Petty said again? Don't do it like that. Don't do it like that. Just because you can do something doesn't mean that you should. Naming it radius would be less offensive than making the radius variable global, but using the same identifier twice just leads to unnecessary confusion. So just don't do it. The second thing about this identifier is that I seem to be violating my own rule about being descriptive. After all, didn't I say we shouldn't call them things like x? But this seems like a reasonable exception since the formula everyone knows is pi r squared. So naming it r probably actually helps with clarity, and since I've already used radius, I think this one is okay. We still have an out-of-scope reference here because our formula refers to radius, so we need to change those to r. That fixes our method so that it compiles, and it should work now. But fixing that error has caused an error in a completely different part of the program. Welcome to the world of coding. Defining a parameter for a method essentially establishes a rule. We're saying that if we want to use the print area method, we have to provide a value for r. The method can't execute without it. So anytime we call the method, we have to provide that value. And that value goes inside the parentheses when we make the method call. When we put a value there, we refer to that as an argument. That can be a little confusing. When we're calling a method, it's an argument, but the variable inside the method definition is called a parameter. Some people use those words interchangeably, but we'll try to be accurate and use the correct term. As soon as I provide that value, the error goes away because I'm now following the rules of the method, as long as the argument I provide is the correct data type. So it turns out we've been using arguments all along, like when we call print or printline. The string we want to output is an argument. In our example, I've provided the numeric literal 14.5. This works and our program will execute without a problem. You can use a variable instead of a numeric literal. Now whatever value the user has input will be passed to the print area method. When an argument is of a value data type, basically all the data types that are numbers, like int and double, the parameter gets a copy of the value. If the code inside the method changes the value of the parameter, the argument value doesn't change. This version of the method results in the same calculation, but in the process it squares the parameter r and puts that value back in r. So r has changed, but the radius variable hasn't changed. Just so you know, this won't always be the case when we learn about objects, but all that stuff will come later. If a method needs more than one piece of data, we can have additional parameters. To calculate the area of an oval, we'll need two different radius numbers, the larger one and the smaller one. So this method has two parameters, small radius and big radius. So now I've basically made a rule that says in order to call the print area of oval method, I'll have to provide two numbers. So my method call has two arguments. I've just used numeric literals here, but those can also be variables, of course. By using parameters, we can pass necessary data to methods, ensuring our code remains organized, reusable, and maintainable.